Alright, hello, Math 101 students. Justin Pashar here again. Hoping everybody is doing well. This is part 2 of the lecture. Last time I did 5.3. This is section 5.4, greatest common factor and least common multiple. So this should help you finish out your homework. I received some questions. It's been good to hear from those that I've heard from so far. Hopefully this will help you a little bit more in terms of the homework. I don't think the homework was all too bad. Just make sure, again, you're reading your textbook. Feel free, call, text, email in the evenings. I'll try my best to continue to help you. Something to keep in the back of your mind too. Eventually, we'll have to figure out something for a test. So when you submit your quizzes and homeworks and stuff, especially the quizzes, I'll get back to you promptly on quizzes, what your grade is. And then check Blackboard for quiz solutions, homework solutions, all those things we posted on Blackboard. So today's short lecture is on greatest common factor and least common multiple, section 5.4. In your lecture notes, if you read them, you would see that GCF, greatest common factor, is the same thing as saying GCD, greatest common divisor. Divisor and factor being the same thing. I typically use GCD more because when I think of divisor, I think of numbers that divide into something. So what is the greatest common divisor? It's the biggest natural number divisor that divides into a group of natural numbers. So we usually look at two numbers at a time. The GCD, the greatest common divisor, essentially that's the biggest number we can divide into both of those numbers simultaneously. For example, the number 18 is the greatest common divisor of 36 and 54. Okay? So what that means is both 36 and 54 are divisible by 18, and 18 is the biggest number that divides both of them. Okay? Now on the other end of the spectrum we have the LCM, or what we call the least common multiple. Now multiples are different. Multiples, I want you to think bigger numbers. These are the smallest natural number that is a multiple of a group of natural numbers. So for example, if we want to look at multiples of 10, that would be 10, 20, 30, 40, 50, 60, so on. Multiples of 20, 20, 40, 60, 80, 100, that's what needs to be a multiple. For example, the number 30 is the least common multiple of 15 and 10. What that means is that 30 is a multiple of 15 and 10, but it's also the smallest multiple that they have in common. Now this is stuff you actually learned in elementary school, and when you sit and read the textbook, you probably think back maybe to elementary school, but this becomes a little bit harder when the numbers get bigger and they're off the wall numbers, not numbers nice like 15, 10, 30, 36, and 54. What happens when we have bigger numbers in the hundreds or thousands? So I'm going to show you systematic ways of doing that. If you looked at your homework sheet, the method that I want you to use to find the greatest common divisor is what we call the Euclidean algorithm. And the book gives you a couple methods, but I told you to ignore the directions, use the Euclidean algorithm to find the GCD for all the exercise sets. And I'll do that next. I like this method because you actually know how to do this because you learned how to do long division in elementary school. And that's what precisely this is. So if you could do long division, you'll be in great shape. So one of the examples was from your lecture notes. Find the GCD between 20 and 36. So find the GCD between 20 and 36. So here's how you do it. You set up a division problem. The smallest number goes on the outside, biggest number is on the inside. It has to be that way, otherwise we'll get decimals, and decimals are not natural numbers. So here's how you set it up. Now we're looking for when we get a zero remainder, because we don't want remainders, but the remainder will be important to us at some point. Here's how the process works. You should know how to divide. How many times is 20 divided into 36? Well, one time. 1 times 20 is 20, and then we subtract. 36 minus 20 on a normal day would be 16. It's not a zero remainder, so we have to go again. So this time 16 is going to go on the outside, and 20 is going to go on the inside. Just like that. So the remainder goes on the outside. This number that was here is now on the inside. 16 goes into 20 how many times? Well, 1. 1 times 16 is 16. You subtract, you get 4. Still not a zero remainder, so we have to go again. So now 4 is going to go on the outside, and 16 is going to go on the inside. How many times does 4 go into 16? Twice? Look what happens. We get a 0. That's what we want. So when you get a 0 for a remainder, you stop, and you go back to the last previous remainder. In this case is 4. So that is your GCD. So the GCD between 20 and 36 is the number 4. So I'll step back and let you think about that for a moment. Again, we're looking for non-zero remainders. And when we find the non-zero remainder, we stop, we peel back, and we go to the last non-zero one, and that's your answer. So the GCD, this is how we typically write it, 20, 36, like an order pair, but it's not, equals 4. That's the GCD. Now this is a very important process because this will allow us to find GCDs of any two natural numbers. Doesn't matter how big or small, it will never fail us. So if you know this process, you'll be in good shape. So let's look at another example. We want to find the GCD between 90 and 168. So again, when you look at numbers like this, 90 and 168, it might not be as readily to you in your mind what the greatest common divisor is compared to two smaller numbers. So we'll go ahead, we'll do the same process. We'll put 90 on the outside of the division sign and 168 on the inside. Okay, so you should have that. Now, how many times does 90 go into 168? Well, only one time. 168 minus 90, it gives you 78. Obviously, this is not a zero remainder, so we need to go again. So 78 goes on the outside, 90 on the inside. We call it an algorithm because an algorithm is just a fancy word for a procedure. 78 goes into 90 one time. 90 minus 78, that'll be a 2. Looks like a 12. Once again, we don't have a zero remainder, so we have to keep going. So 12 goes on the outside, 78 on the inside. Okay? How many times is 12 divided into 78? Do you know? I think we can only get 6 times. 12 times 6 is 72. So 78 minus 72 gives you a 6. We're almost there, but not quite. So we have to ask how many times is 6 divided into 12? That's nice. That's 2 times with a zero remainder. So remember what I said? When you get a zero remainder, you stop and you go back to the last non-zero remainder. In this case, is 6. So the GCD between 90 and 168 is 6. Okay, so I hope that you understand the process. It's not too difficult. And again, this will always work for us when we're comparing two numbers. If you ever had to compare three numbers, you would have to pick the first two, find the GCD, and then take this number and compare it with the last one, but I'm not going to do that to you. I'm not that mean. Not yet, anyway. So I would encourage you to pause this video perhaps if you want to go back and redo these last two examples or do the textbook assignment problems. Because the next part is going to be the LCM. Okay, welcome back. The nice thing about finding the least common multiple is we actually have a formula for this. So here's what the least common multiple is. The least common multiple between numbers m and n is found by taking m and multiplying it by n and dividing it by the GCD of m and n. So in other words, if you find the greatest common divisor, then it's very easy to find the least common multiple because you're just going to plug that number in here and multiply the two numbers that you have in question, and that's it, you're done. Okay? So here's an example. We want to find the LCM between 90 and 168. So that was actually just the last example that we did. So recall that the GCD between 90 and 168, remember just a few seconds ago we found was 6. So all we got to do, use a different color, to find the least common multiple between 90 and 168, we take 90 and multiply it by 168 because that's what the formula says. So 90 times 168 and divide it by the GCD between 90 and 168, which we previously found to be 6. So all we got to do is the multiplication on top and divide by 6. Now, rule of thumb with this type of thing is that if you end up getting a fractional answer, you've done something wrong either here or with finding the GCD, because we'll always get some kind of whole number out. So if you end up getting a fraction here, something has been done wrong in one of the previous steps, and that's a warning or a red flag for you to go back and check out what happened previously. So if you take care of this right here, you're going to get 2,520, and that's what the least common multiple would be. And you could go back and look at some of the other examples from your notes in the textbook, and you'll be able to check your work and see if you can do this. It's very simple. So with that being said, I hope this video has helped you with a couple examples. Again, if you need help with textbook exercises, feel free, call, text, email. Tomorrow's class, so we'll find out tomorrow what we're going to do. Until then, stay safe and enjoy the rest of your day.